All right, here we go, day 41. Today's lesson is our second lesson on comparing polynomial functions, 5.3b. The 3-minute review is some review stuff with a little bit of new stuff just sprinkled in there for flavor. We've got a function here, and we're asked to describe the end behaviors. Well, we can see that it starts high and ends high. That's what we're interested in. So starts high, ends high, but that's not good enough. We need to write it in math form, right? So starts means off on the left. That's as x goes to negative infinity, way off on the left. High is y is at positive infinity, right? Starts high, and that's the first start. And the ending, when x goes off to positive infinity on the right, what happens to the y values? Well, they're at positive infinity as well. Turning points, how many are there? Well, I can see there are 3. And they're labeled, actually. The x-intercepts, 1, 2, 3, 4. 4 x-intercepts. No scale, so I can't state what they are. So the degree, probably a degree 4. We know that because we know it's even because it starts and ends in the same spot, either high or low. We know the number of turning points is 1 fewer than the degree, and the number of intercepts is 1 fewer than the degree. And that's most likely. Other weird stuff could happen. But here's some notes. Q, this point Q, is called a relative maximum. And that kind of makes sense. Relative to the points that are around Q, it's the highest, right? So it's a relative maximum. And then P, of course, is a relative minimum, because relative to the points that are close to it, it's the smallest, or it's the most negative, or whatever. Point R, on the other hand, it's as low as the function goes in total. It's called an absolute minimum. I also call this a global minimum. So if I consider the entire function, R is as low as it goes. P is as low as it goes when we just compare points that are close to P. It's a relative minimum, but R is an absolute or global minimum. Notice that R is also a relative minimum, right? Also notice, many alsos, that this function, because it keeps on going up, it doesn't have an absolute maximum. It keeps going up and keeps going up forever. There's no absolute maximum for this function. Okay, today is another one of those investigation type things. So you may want to stop right there and take there's a sheet in your package called What Role Do Factors Play, and do that right now. Now that could be you could save that in class and have sort of double videos tomorrow or the next day for homework, or you could do this right now and then get back to the video. So in the video, I'll take up this sheet, show you what you're supposed to get out of that, and then I'll do a couple of examples, and then you still have homework and FAQ, but you might want to wait for half a period to do that. That'll be up to you. In just a second, I'm going to move on, but you might want to stop and then wait to class to do this, or you might want to just pause the video and do this you'll need to use the graphing calculator, right? You need a TI-83 or some sort of graphing, an app on your iPhone or something that will help you graph functions. All right. So what you're supposed to get, I'll show you the answers there, and you try this on your own, I know. So And your pictures might not look exactly the same. Notice that we don't have any scale on the y-axis, so yours is going to look different than mine if you had different window settings. What's important here are the x-intercepts. You're supposed to get this idea of the x-intercept. So the x-intercepts for this function were 2 and minus 1. This one was 2, minus 1, and minus 3. And then we are able to sketch those. And I'm going to go through them real quick here. Some of them look strange because the points are so close together. It looks a bit weird, but every bracket essentially gives you another x-intercept. And I want you to mark those with a big fat dot. Now, of course, what we want to be able to do is be given a function like this and then able to graph it without a calculator, right? We're not going to have a calculator forever, so we want to be able to do this without a calculator, and that's the goal. So what were we supposed to get out of that activity, that investigation? Well, if I had a polynomial function that looked like this and could go on for forever, first of all, we're supposed to realize that it has zeros this number. When it's minus x1, it has zeros there, 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 and so on, right? All of these numbers. These numbers are all x-intercepts. And if it was x plus some number, then negative r would be the root, right? We figured that out, I hope. Okay. So what does it look like? Well, if there's the exponent, there's no exponent, or the exponent is 1, it's what I call a slash. So the x, where we have an x-intercept there, it sort of just goes right through. It slashes right through. And notice that kind of looks like a line, right? That kind of looks like a line. If we had a root that had a squared on it, like x2 here, it's got a squared on it, then it behaves like a parabola. It what I call bounces, right? So it goes like this. Now it might, by the way, it might not be like that. It could be the other way, right? It could bounce this way, same as this one. It could slash through this way, and we'll talk about that when we get to the examples. Okay. What about if it's a cube? And this goes on and on and on. We could have factors with 4s and 5s and stuff like that, but as far as we're going to get up is cubed. So x cubed, I call it a slide. You might call it a snake shape or something like that, but it sort of comes down. It looks like it's going to bounce, and then it slides through. And again, it might go like the other way, but slide. All right, so the idea now is we're going to put what we learned last class together with this fact, and we're going to be able to graph some stuff pretty quick. That was the homework, or the investigation. The homework is coming. So notice that if I were to expand all this out, I'd have an x to the exponent 3. This is of degree 3, and I see all the x, the numbers in front of the x are positive, so the leading coefficient is positive. And this is sort of, I'm thinking about yesterday's stuff. So what does that mean? It means it starts low and ends high, right? Odd degree, leading coefficient positive. It's kind of, overall, it's going to look something like that. But now we know stuff about the x-intercepts, right? So we have the x-intercepts, minus 3, 2, and 5. And all of them are single root, so it's all going to be slashes. Now, the idea here is minus 3, 2, and 5. I'm going to put all this stuff together. I know it starts low and ends high, and all of these are slashes. So notice that it can't come this way because it's got to hook up with starting low. So I know it's going to slash through this way. And I know this one's going to slash through this way. It can't slash through this way because it's got to hook up with here. And this has got to hook up with here because it's got to end high. So what's this graph going to look like? Something like that. It's not beautiful, but what's important is that you show the end behaviors and you show the roots, okay? The x-intercepts and the roots. So, well, what about the y-axis? I don't know how high up to go. Basically, we just draw a nice smooth curve, and then we take care of what these points are later. So I'm going to pick a point, usually a nice point, and figure it out. Like when x is 0, what's y? Well, I'm just going to figure it out. Use a calculator if we wanted to, I suppose. That's 30. So that means that point right there, the y-intercept is 0, 30. Say, well, I don't know how far to go down there. I don't know how, if this is a maximum is 30. Don't worry about it. This is all we need to be able to draw. And we can do these pretty quickly now, I hope. Notice we got 1, 2, 3, 4 brackets. So that means degree 4, which means, and it's a negative out front, so the leading coefficient is negative. So it means it starts low and ends low because it's degree 4, starts low and ends low, so I know it's going to start low and end low. And then I've got my roots. Notice when I have no bracket there, this is kind of like x minus 0, right? Now we would never ever write in the minus 0, so this is an x-intercept of 0. This is an x-intercept of minus 2, and an x-intercept of minus 5. The only difference here is this one has a squared on it, so this is a bounce here. And I just got it. These are slashes. 0 and -5 are slashes, so I'm going to put those nice big fat dots on those roots. -2, -5, and 0. And I got to start low and end low, but I've got a bounce here. So how does this work? Well, I can see -5 is a slash. It's going to slash right through here. And at -2, it's going to bounce. Notice it's not going to bounce from underneath because I've got to hook up with this, so it's going to bounce here. And 0 is a slash, so it's going to slash through there. And then end low. Now this looks weird here. It's not going to be quite smooth, but I can hook it up pretty good. Yeah, done. Say, well, okay, what about a point so I know how high this is? Well, notice I like getting the y-intercept, but we already have that. That's the 0.00. So we just pick any other point that's nice for us. I'm going to pick 1 since 0 is gone. So -1 times 1 plus 2, 1 plus 5. Hammer that into your calculator, and you get, let me just look here. Should just be thinking about this. -54. Say, well, that doesn't look like -54. That's quite a scale. Well, who cares? We listed that point on there. There. Now there is scale. This is 54. So these bumps are actually going up pretty high. We don't know how high to go, and we don't care. One more. One more? One more? Yeah, one more. One bracket there, and this 3 means there's like 4 brackets there. So this is degree 4. Leading coefficient is positive. So I know it's going to start high and end high. Start high and end high. Start high and high. And then I've got x-intercepts 1 and -4. And this one is a triple root, which is a slide. So I got to figure out how to do that. There's 1 and -4 is right there about. -4. And I got to start high and end high. So I know the slide is going to happen this way, and the slash is going to go this way so it can end. All right, so this is a slide. It looks like it's going to bounce, and then it slides through. And this is a slash here, and then I sort of join it up so it looks nice. And I'm going to calculate one single point. I like the y-intercept there. X is 0. 0 minus 1, 0 plus 4 to the exponent 3. This is -64. And so that point right there is 0, -64. And that is a graph of that function. That's pretty good, seeing as we started with the TI-83s, but now we don't need them as long as it's in this form. So Tonight's homework is on a page, and you should be able to zoom right through it. It should only take a few minutes to get that done. You can check on the TI-83 or with one of your classmates to see if you've got it right or not, okay? I'm also hoping to post the homework. The homework page kind of looks like this, but it's homework, not the investigation. If you remind me, I'll put that up at the back of the room for you to check your homework, okay? So that's it.